Welcome back. Welcome back to my channel, Our Soils. So today we're going to discuss about another important major topic in pedology, in soil science. It is weathering of rocks and minerals. So now we will see what are the conditions and what are the privileges what are the situations present in the rocks and minerals, and what kind of weathering will be happen in the soil. We will see. Very first, we want to see what is the definition. What is the definition of weathering? No, very first, there are many definitions. Many authors will give many different types of definitions. Many authors will give very kind of definitions. But let us see some standard definitions present in weathering. Well, very first definition is a process of disintegration, decomposition of rocks and minerals which are brought about physical agents and chemical processes. Remember, it is a physical agents and chemical processes leading to formation of regolith. Regolith is nothing but unconsolidated residues of weathering rock on the earth's surface or above these solid rocks. So this definition clearly says that weathering mainly influenced by the two agents, that is called physical agents and chemical agents. He said that chemical processes, remember that in this definition he mentioned about the chemical process and physical agents. They are different agents like water or animals, you know, or some other physical mean of agents are there. In chemical process, there will be only process. So overall, this definition is saying that a process of disintegration, decomposition of rocks and minerals, which are brought about by physical agents and chemical process leading to the formation of regolith. This is one type of definition. Coming to the second type of definition, which is somewhat very short, the process by which earth crust or lithosphere is broken down by activities of atmosphere which aid of hydrosphere and biosphere. So students, this definition is very simple. This is the process by which earth crust is nothing but a solid surface of lithosphere which is broken down by the activity of atmosphere with the aid of hydrosphere, means water and biological factors. See, atmosphere, some physical mean, hydrosphere and biosphere. Biosphere is one biological weathering, hydrosphere, water, which is made of physical. Oh, this is also very somewhat very lengthy. Now we will see single short of definition. The process of transformation of solid rock into parent material or regolith. This is called another type of definition. So overall, these are the three type of definitions. But remember, students, whatever the definition might be, all the definitions will give only one kind of intention only. What is that? It is always mentioning about some physical agents and chemical process only. So in this definition itself, it says that there are three different activities will be followed in a weathering. There are physical, chemical, and biological process. Now we will see about one by one what about that. Very first, students, we will see very first in weathering parent material. So parent material, which is a source for the weathering. Parent material is very important. Now we will see what is a parent material. It's a regolith, or at least its upper portion may be defined as unconsolidated and more or less chemically weathered mineral material from which soils are developed. This is a regolith. It is a regolith. Parent material is nothing but it's a regolith. The upper portion, mostly upper portion, and we can say the soil was not that much developed in the parent material. It is no chemical activity was very less in this position. So those are called the parent material. Now we will see next. So how many types of weathering are there, sir? Very first is a physical weathering. Physical weathering mostly you can see disintegration. You can see disintegration. And another one, chemical weathering, that is called decomposition. You can see decomposition. And finally, it is a biological weathering. So this is actually, these two will lay some foundation for this biological weathering. The overall, students, there are three types of weathering are there. The physical weathering, chemical weathering, and biological weathering. So naturally, depending upon the agents taken part in the weathering process, classified into three types, as I mentioned above. Now we will see, students, in different agents of weathering. In physical weathering, how many agents are participating? What type of process are there? Let's come into this. Let's count those agents. So physical or mechanical, it's a disintegration process. So in this, we can see physical condition of the rock, which is very important, and change in temperature is one type of condition, and action of water, which is mainly mentioned in our definitions. So action of water, in action of water, we can see fragment and transportation, action of freezing, wet and alternate wetting and drying conditions we can see, an action of some glaciers, mostly in polar caps, we can see this type of conditions are prevailing, and alternate wetting and drying during our diurnal variation of our temperatures, we can see this type of conditions. And transportation, all these things are very we will see and we will read all those things. And finally, action of wind and atmospheric electrical phenomena. So these are the conditions which will be taking place in the physical or mechanical weathering. Coming to the chemical weathering, it is hydration, addition of water, hydrolysis, breaking down of water. I mean, OH and OH plus ions will be take place a major role in this hydrolysis. And the third one is solution formation, carbonic acid influence, and oxidation and reduction. So these are the reactions will be taking place in the chemical weathering. Coming to the biological, it is a combination of these both, the disintegration and decomposition. Mostly man and animals, we human beings always disturb the earth surface by our regular engineering activities, and animals, yeah, for the burrowing animals will do some, they will also contribute something for the weathering, and higher plant roots and their segregations, like they will release some acids, or sometimes during the respiration they will release the carbon dioxide, so that carbon dioxide will combine and it lays the foundation for the chemical weathering. And coming to the third one is called microorganisms. Yeah, this is very important. They will release, and they will release some acids and release the important mineral nutrients from the soil, and which makes the available to the plants. So these are the few things which has happened place in the biological. So overall, students, these are the phenomena which is happening in our regular three types of weathering: physical, chemical, and biological. Now we are going to discuss about one by one about this type of conditions. Very first, student, we will see about physical weathering. So physical weathering, now we can see it's a very first line. The rocks are disintegrated and are broken down to comparatively smaller pieces without producing any new substance. Here you can see, if you take a very big rock, it is only physically damaged. I should not use damage. It was physically weathered. It was physically weathered, but you can't see any formation of new compound. The same compound will be present. There is no formation of any new compound. Only the physical nature will be. That means big size of rock was converted into a small pieces. It is only happening, but no, we can't see any chemical changes in that particular rock. What is the next line is saying? The permeability of the rocks is the most important single factor. Permeability means coarse texture, that is porous texture, sandy, weather more readily than the fine texture, almost solid basalt. So naturally, coarse texture soils will be weathered more readily when compared with the fine texture basalt rock. Now let us see very first one, unconsolidated volcanic ash weathered very quickly, student, as compared with unconsolidated coarse deposits such as gravel. Unconsolidated volcanic ash will be weathered very fast when compared with unconsolidated coarse deposits such as gravels. Now we will see another important factor. It's called action of temperature. Action of temperature, which has a greater influence on the disintegration of rocks. As I said, it's a daytime. During the daytime, the rocks get heated up by the sun. Actually, there is not. And in night time, the temperatures will be falls. What happens during this cooling and contracting process? What will happen? There will be expansion contraction process. So during this extra expansion and contraction weakens, the surface rock will crumbles and it becomes rock do not conduct heat. The surface, it will be very weakened due to this contraction, weakens the surface rock and crumbles. It's because of rocks do not conduct any heat. So generally rocks will not conduct any heat, but due to this expansion contraction and due to this it weakens the surface rock conditions, everything. This happens because why this contraction happens? Surface rocks will crumble. Only surface will be crumble. Why? Because rocks are not conducting any heat. The minerals within the rock also vary in the rate of expansion contraction. That is also a very important factor, students, especially the minerals factors which are present in our soil also plays a major role in this expansion and contraction. The cubical expansion of a quartz is twice as feldspar. Just this is the explanation for this point. The cubical expansion of quartz is twice when compared with the feldspar. The dark color rocks are subjected to faster changes in temperature as compared to the light color rocks. Naturally, light colors will observe very less heat compared with the dark colors. This is also very important factor. Now we will see next one. So continuation to the previous slide. The differential expansion of minerals in the rock surface generate a stress between the heated surface and cooled unexpanded part, resulting in the fragmentation of rocks. Due to this change, this difference in temperature, surface inside where the surface area will be very heated up, there will be expansion, but inside the rock, there will be very cool surface. So due to this changes, due to this change, difference in temperature in the rock itself or in the mineral itself, what will happen? A rock will be fragmented, the rock will break down, or rock will become very fragmented. So this process of surface layer will be peeling off from the parent mass and rock ultimately disintegrated. This process is called exfoliation. Generally, students, due to this, surface area will be heated very hard. You know, the surface area will be very heated very hard, but inside the rock will be very cool. Due to these changes in temperature, what will happen? The surface upper part of that heated portion will be removed, that will be peeled off. So this type of weathering is called exfoliation, or informally I can use one word called onion weathering, or I can say exfoliation. What is that, sir? I will show some images. These are the best examples. See, this is called the exfoliation. You know, the surface area, the surface of the rock was completely heated up, but inside the rock there is not that much heat because it is very cool. So due to this changes in heat and cool conditions prevailing, what will happen? The surface layer will be slowly will be peeled off. So this is called the exfoliation. This will be happen due to the changes in temperature in the rock. So inside the rock is very cool when compared with the surface layer. What will happen? As the rock will not collect any heat, generally what will happen? The surface will be peeled off. This is called the exfoliation. Now we will see the next one. And next, coming to the next one is our water. How the water will act? Water will be acts. Very first, water agent. There are few agents. Very first, students, water will first disintegrate it. Water will use some disintegration. What will happen? And after beating action of water, what will happen? The rock will be disintegrated. After the disintegration, what will happen? It will be transport. It will transfer. So it will transport the material to some other portion. And again, what will happen? This water will deposit whatever the soil materials, what are the soil particles. I should not use soil particles. What are the weather product has been taken by the water, will transport water will be deposited in the some other in the lowland areas. So you know, there is a lot of classification, and we will read many things about these depositions in the coming videos. We will see what is those. Very first, students, fragmentation and transportation. We will see. So as we know that water has a tremendous energy when it is which has a, when we place a due to its very when the energy was converted into kinetic energy. So it has a tremendous energy. So now see, water beats over the surface of the rock when the rain occurs has started flowing towards the ocean. You know, that's what happens. So when the moving water has a greater cutting and carrying position, so moving water will have a lot of energy. So what happened? Due to that greater energy, it will cut and carry the force. And during this time, you can see some gullies, raviries, and carries with suspended soil materials. During this carrying material, during this water movement, we can see some soil material, some solid materials will be carried. So transporting power of the water will be varies. The transporting power of soil will completely vary, students. That depends upon the size of the particle. It estimated that transporting power of the stream varies some sixth power of its velocity. That is, greater the speed of the water, more the transporting power of the carrying capacity. So when the water was moving very fast, you know, the carrying power of the soil particles also will very high, and this carrying will be different as explained in this table. You know, if your water was moving around 15 centimeters per second, it can carry about the fine sand particle. But if it is doubled and 30 centimeters, means it can carry up to gravel. It can take up to gravel. If it is 1.2 meters per second, your water was moving very fast, is around 1.2 meters per second. It can even carry the rocks. Sorry, I should not use rocks, stones, up to 1 kg stones we can see. And it is moving around 9 meters. Now it is very too much of energy. So there you can see some bulldozers, several tons of bulldozers will be carried out by the water. So these are the fragmentation section of the transport. Let us see another important aspect: freezing and thawing. You know, freezing and thawing. What will happen means during you know, especially this type of phenomenon we can see in some frozen condition where the water was completely frozen, the cracks and crevices. What will happen? Just this is the best example, students. So this is a crack. You know, this is a crack. In this crack, you know, water was collected due to some precipitation or something. What will happen when the temperatures was fall down? Water will get what will happen? Water will get freezes and expands and froze. The crack will be widened. So here is a very small crack, but when the water was completely frozen, what will happen? The crack will be widened and widened. So when the ice thaws, ice was completely developed, what happened? Contracts, water get deeper and deeper into the crack. What will happen? Finally, it splits into two. So a single rock will be ultimately we can see two pieces. So repeat expansion. So this complete repetition and expansion, what will happen? The rocks will be broken down. So this was a continuous process. After when these rocks were fallen apart, you can see here there is, you can see some small crevices. So here also accumulation of some water will be taking place. Same reaction will be repeated. Some freezing will be there, some thawing will be there, crack will be expanded. What will happen? The rock will be broken down. So this is called the action of freezing. Coming to the next, alternate wetting and drying. Very important aspect we can do. So some natural substances increasing considerably in volume on wetting and shrinking on drying, especially Smith site. In Montemorillite, we can see this 2 is to 1 type of clay. It is a Montemorillite is a 2 is to 1 type of clay due to it has a very special character called expansion type. So during the dry summer or dry weather, these clays shrink considerably, forming a deep crack or wide cracks. Especially this type of crack, this deep cracks we can see in black cotton soils. Especially in India, black cotton soils are very famous, especially in Tamil Nadu or in some southern states of India. We can see these black cotton soils very rarely. So here we can see that due to this presence of this type of clay mineral, Montemorillite factor, due to this expansion and contraction, what will happen? There will deep cracks will be formed. So subsequently, what will happen due to the expansion? When the moisture comes, what will happen? The Montemorillite will be expanded. That will be expanded. So this alternate swelling and shrinking, weathering or drying of clay enriches rock to make them loosen and eventually break down. So this alternative, this wetting and drying conditions, what will happen? As the expansion contraction leads to the weakening the rock conditions, and what will happen? It leads to the breakdown of the rock. This is regarding the alternate wetting and drying conditions. Coming to the action of glaciers, mostly happens in polar caps. It's a cold region. When the snow falls, it accumulates and changes into the ice sheets. So the big glaciers start moving owing to the changes in temperature and pressures. And when this was moving, when these ice caps are moving, this ice was moving, this glaciers was moving, what will happen? They exert a tremendous pressure over the rock on which they passes and carry the loose material. So whenever these glaciers will move from higher altitude to lower altitude, I mean higher to low land positions, what will happen? They exert a tremendous pressure over the rocks, and they process even carry the loose material during this journey. So these materials get deposited and reaches the warmer region, and where the movement stops, which melts the ice. Generally, what will happen when this glacier was moving from highland to lowland? So generally, whatever the possible solid material will be transported by the glaciers and the deposited in the lowland. What will happen? The ice will be melted. It will go off as a water, but the depositions will be settle in that particular area. This is will be this is one type of weathering taking place in the action due to the help of glaciers. Coming to the next, students, wind. Mostly some desert areas we can see. Mostly wind has a erosive transport effect. Often very fine material like fine sand, silt, or clay material. There's a serious abrasive effect, and sand line winds itches the rock and ultimately break down under the force. So whenever these fine particles are moving on the rock, what will happen? It will give some itching effect. It will give some itching effect. What will happen due to the itching effect? It expends some tremendous force and leads to fall. So dust storms may transport tons of material from one place to another. Shifting soil causes serious erosion, wind erosion problem, may render cultivation land in degraded conditions. Especially when this wind condition was prevailing very too much, what will happen? It leads to soil erosion. And what happened? All the cultivated land will be degraded. So mostly this type of problems will be seen in Rajasthan deserts in India, especially Thar desert in India has this type of problem. In wind erosion, I can say due to the action of wind, what the major fertile topsoil was completely taken away by the wind and will be deposited in some other area. And during this traveling, what will happen? It will show some itching effect on the nearby the rocks and give some important effect on weather. So this is regarding the action of wind. And electrical phenomena. It is an important factor causing down when the rainy season. What will happen? Lightning break down the rocks and widen the cracks. Whenever the light was fallen upon the rocks, what will happen? Will you widen the rocks and break down? Just generally, we can see the thunderstorms during the rainy seasons. We can see this phenomenon in raining conditions or thunderstorm conditions. This is electrical phenomenon conditions. Finally, we have reached to the chemical weathering. So up to now we have seen a physical weathering. Now we will see the chemical weathering. In chemical weathering, you can see it's the decomposition of rocks. It's completely changed. In physical conditions, only we can see all the whatever the bigger size of particles are converted into small size. But there is no change in their original content. Original content is as same. But in chemical weathering, not like that. The content of the mineral will be completely changed. That's why it's a decomposition of rocks and minerals by various chemical processes called chemical weathering. It's the most important process of soil formation. Very important process, students. Especially we can see the pedogenic process that what we have seen in our previous videos. If anybody have not seen that video, please go through that video of my previous lectures. So another one, chemical weathering takes place mainly in the surface of rocks and minerals, which disappear of certain minerals and formation of secondary minerals. This is called the chemical transformation. So what is happening in this chemical weathering? So whatever the primary minerals are present, whatever the rocks and minerals are present, what will happen? It will be converted into secondary products. That is called new material. Those are called the secondary products. Those are very important in the chemical transformation. So chemical weathering more effective as the surface area of rock increases. This is what happening in our physical weathering. In physical weathering, what happened? The surface area was increased. The bigger size of rock was converted into very small pieces. So ultimately, what happened as the particle size was decreased, the surface area was increases. So this give a seat for the chemical weathering. Very important aspect. Since the chemical reactions occurs largely on the surface of the rocks, therefore, the smaller the fragments, the greater the surface area per unit volume available for the reaction. Just now, what I have said was put it in the sentence formation. And coming to the last language, the effectiveness of the chemical weathering is closely related to the mineral composition. Example, quartz respond very far slowly to chemical attack than olivine or rocks. So generally, chemical content, the mineral content, the chemical composition or mineral composition of rock also is a major factor which influence the chemical weathering, especially quartz, very resistant, so it shows some, so it will respond very slowly for the chemical attack, but when compared with the olivine or pyroxene. And coming to the next slide, it is called chemical process. Now we will see one by one what are the processes involved in the chemical weathering. Very first, student, hydration. Hydration, it's a combination. Hydration. We are adding some water. That is one of the chemical. Anybody has some chemical interest in chemistry? They can identify hydration means nothing but addition of water. Let us see my first line itself is explained that part. So chemical combination of water molecule with a particular substance or a mineral lead to change in the structure. What will happen whenever this water molecule is added? So what happened? The chemical structure will be changed. So what will happen? Soil forming minerals in the rock do not contain any water as they undergo hydration when exposed to the humid conditions. Generally, rocks will not contain any water, but when exposed to the hydration, exposed to the humid condition. Upon hydration, what will happen? They will swell and increase in volume. As the water molecule involved in that particular mineral, what will happen? The volume will be increases. So the mineral loses their luster and become very soft. It is one of the most common process in nature as works with the secondary minerals such as aluminium oxides and iron oxide minerals, the gypsum. So generally, as the water molecule was involved as addition of water molecule taking place in that mineral, what will happen? So it is one of what will happen? The mineral will be very loose and luster and become very soft. It is one of the very common process occur in our nature, and especially in secondary mineral will happen. Mostly in aluminum oxides and iron oxides we can see. So these are the best examples, students. This is olivine. So whenever the water molecule was added to here in this structure, what will happen? It is converted into serpentine. So when the hematite is very red in color, this iron oxides it was added. Sorry, converted to the limonite, its color was changed into yellow. Bauxite, and the bauxite was added, hydrated aluminum oxide was converted. When it was added to the calcium sulfate, what happened? What was anhydride? What happened? It was converted to the gypsum. So this is what, see, the chemical composition was completely altered. Just addition of one water molecule. What happened? The chemical composition was completely changed. The mineral nature also is completely. Olivine was converted into serpentine, hematite was converted into limonite, and bauxite was converted into hydrated aluminum oxide, and calcium sulfate was converted into gypsum. So this is the nature. It is hydration nothing but just addition of the water molecule to your rock minerals, and will lead to the formation of new secondary products. And next one is hydrolysis. Lysis in chemistry, we can see lysis is nothing but breaking down. So here are the dissociations. Most important process in chemical weathering is due to the dissociation of H2O into H plus and OH minus ions. So ions in which chemically combine with minerals bring a lot of changes such as exchange, decomposition of crystalline structure, and formation of new compounds. So water will act as a very weak acid in silicate minerals. So these H plus and OH minus ions will be lead to some exchange reaction, to give some exchange reactions, or sometimes it alter the decomposition, to decompose the crystalline structure of the component and leads to the formation of new compound. Just example you can see here. So orthoclase was completely changed into the acid silicate clay by the addition of this. So potassium was came out, So hydrogen was added here. What happened? It leads to the acid silicate clay. So hydrogen aluminum silicate clay was came out, or the instead of orthoclase. And coming, same thing was happening here. Again, it was combined with another which mechanisms. What will happen? So recombinations. Again, it was recombined. What will happen? Again, aluminum oxide was converted. Aluminum oxide and silicic acid. So H2SiO. It's completely divided. So addition of again H plus and OH minus leads to the formation of hydride aluminum oxides. So coming to the next one, is called this reaction is very important, especially in clay, bases, silicate acid. The substance formed in these reactions are highly available for the plants. That's what happens. So then due to these reactions, what will happen? There is a release of some minerals will be taking place. All this will be happen. So water often contains carbon dioxide. So generally, what will happen? Water contains almost often which someone has some absorbed from the atmosphere, and this will react directly to produce some insoluble clay minerals, especially positively charged metal ions of calcium, magnesium, sodium, and potassium, and negatively charged ions of OH and HCO3 ions, and some soluble silica. All these ions are made available for the plant to grow. Generally, what will happen whenever this was released, especially all these are all major secondary and nutrients which are useful for, of course, these are primary. All the secondary and potassium primary, and all are useful for the plant growth. So this is regarding the hydrolysis. Coming to the next slide, is a solution. Solution is nothing but is a substance present in the rock are directly soluble in water. Some substance, especially sodium chloride, will be soluble, readily soluble in water. These soluble substances are removed by the continuous action of water, and the rock no longer remains solid and forms some holes and rills, rough subsurface, ultimately fall into pieces or decomposition. Generally, whenever the substance was dissolving, started dissolving in water, directly dissolving, what will happen? That rock will form, some holes will be happen, some drills will be formed, rough surface will be formed. That will easily leads to the weathering, chemical weathering will started taking place, because the chemical nature is completely changing due to this dissolving process, due to the formation of soil. The action is considerably increased when the water is acidified by the dissolution of organic and inorganic acids, halides especially. This is the best example. Sodium chloride. Whenever the sodium was dissolved, it was sodium plus chloride dissolved in the iron. So whenever it was dissolved in water, the ionic nature, the ions, it was split into Na plus and Cl minus. So this again it will be contribute something for the solution. So this is a continuous cycle, and leads to the formation of solution, and ultimately it forms some holes and rills in the rocks, leads to the weathering, chemical weathering. Another one is called carbon dioxide. Carbon dioxide, when dissolved in water, it form a carbonic acid. It's to CO3. This is very hard. This is a very weak acid, carbonic acid. So carbon dioxide is a very important carbon dioxide. Where the carbon dioxide mostly comes from the atmosphere, or sometimes the respiration process are taken place by the roots has taken place. This carbonic acid attack many rocks and minerals and brings them into solution. So the carbonate water has a itching effect upon the rocks, especially lime. If it is there is lime, especially you can see that they remove all this cement holding the particles together and leads to the disintegration. Whenever this carbonic acid has some itching effect, so at first it will attack on the binding material or holding cementing material, and they leads to the all the particles will be leads to the disintegration. So disintegration leads to this some weathering, some chemical weathering type will be taken place. This is called the carbonation. And finally, it is called oxidation. Very important is the addition or combination of oxygen to the mineral. So yes, this is a very famous reaction usually we will see in a chemistry lab. It's an oxidation, the process of addition and combination of oxygen to the minerals. The absorption is usually from O2 dissolved in the soil water and the present in the atmosphere. The oxidation is more active in the presence of moisture, resulting in hydrated oxides. Mineral contain especially iron and magnesium. So iron oxide, whenever it combined with oxygen, what will happen? It's called ferric oxide. So ferrous will become ferric. Ferrous ferric. So magnetite was converted into hematite by the addition of water. And hematite, again, if there is the addition of water, there is oxygen here. What happens? It converted into limonite. So like this, addition of oxygen also will leads to the formation of new compounds. So this is what the chemical weathering. Here there is one compound, but due to the addition of oxygen, we can see another new secondary compounds. This is the new compound in weathering. This is called the chemical weathering. And finally, another one is called reduction. It's the process of removal of oxygen or reverse of oxidation. Especially in the reduction is nothing but somewhat removal of oxygen, or simply we can say it's the reverse of oxidation, and is equally important in changing the soil color to gray, blue. We can see the gray, blue, green, or ferric ions to convert into ferric compounds. Especially whatever the motile colors usually see whenever the soil was under submerged conditions, we can see this type of colors: gray, blue, gray mottles, blue mottles, green and ferric ionic mottles. We can see all this type of mottles in ferrous compounds. We can see submerged conditions. So under the condition, excess water, waterlogged conditions, where the less oxygen will be taking place, we can see this type of conditions. Okay. So overall, students, here ferric ferrous, I think ferrous, yeah, ferric compound was completely oxygen was removed. So again, it was converted to the ferrous oxide. So it is a reduced form. It is a oxidized form. It is a reduced form. In conclusion, during chemical weathering, igneous metamorphic rock can be regarded as involving in disintegration of primary minerals and production of secondary minerals. So overall, students, in chemical weathering, especially in igneous and metamorphic rock, can be regarded as involving in destruction of primary mineral and production of secondary. In sedimentary rocks, which is made up of primary and secondary, especially in sedimentary rocks, this is regarding the igneous rock, students. In igneous rocks, what will happen? It will be involved in the disintegration of primary minerals and production secondary products. But in condition of sedimentary rocks, which is made up of primary and secondary minerals, weathering act initially to destroy any relative weak bonding agents, especially iron oxides, ferrous oxides, and particularly fluid and can be individually subjected to the weathering. So whenever in sedimentary, we can see bonding will be released. Whether it is any mineral, the bonding will be released and makes individual particles, and later it go for the weathering process. So this is regarding the reduction. Coming to the biological weathering, students, it's a very simple, students. Mostly all the human beings, all of the animals present in the on the mother earth will contribute something for the weathering. Especially we human beings, we always, whenever we go for any engineering structure, especially when construction for dams or irrigation channels or roads, buildings, we started doing some activity which influenced the disintegration of rock. And when the big size of rock was converted to small, and that leads to the formation. And coming to the birds and animals and insects, they may drill holes. They may drill the holes, and especially some rodents like rats or even rabbits also will burrow the ground, and they will contribute to the contribute the rock. So during this burrowing condition, what will happen? The rock will become very soft. If it's continuous burrowing condition, what will happen? The mineral will be softened and will leads to the leads to the formation of secondary compounds. If it is a chemical condition was very favorable. At the same time, moles, ants, and all the even dead bodies of animals also provide some substance. Whenever the dead bodies was decayed, what will happen? Some acids will be released. Those that will be also will be contribute something to the something to the for the formation of soil, weathering of soil. And also when earthworms were passing their soil into their alimentary canal, what will happen? We can see there is a during the passing of this alimentary canal, whenever earthworm was consumed as soil, what will happen? Some castings will become, so that during the formation of casting, there you can see lot of physical chemical changes in that particular soil material. That's why earthworm, whenever the earthworm were present in the soil, we can see the soil was very live and we have some life in that particular soil. So these are the contributions. Highlighting biological weathering is very common. Everybody knows. There's no need to go for that much explanation. It is very easy to understand when compared with the previous two types of weathering. Anyhow, and coming to higher plants, as I said, plants and roots generally plant whenever the plants are started, especially when you see the hillside, you can see plant roots are completely penetrate to the crevices and cracks in the rocks. Whenever they passes in the crevices and rocks, what will happen? They started breaking down that big rock. And also and also there will be some growth of some small sponge mass and some parent plants. What will happen? The moisture, the acids released by those roots, what will happen? They will soften they will soften the rock and leads to the weathering of rock. And also they will release some carbon dioxide, so that carbon dioxide will form combine with water present in the soil, and it leads to carbonic acid, the carbonic acid weak acid, so it leads to the carbonation reaction. So ultimately it is a link up with the chemical weathering. So all these conditions, higher plants also contribute something for the soil weathering. So, and also microorganisms, students, as I explained, microorganisms also it's an early stage of decomposition, especially when the big plants, like when the lower form of plants, animals like mosses, bacteria, fungi, actinomycetes also plays a major role. They extract the nutrients from the rock, especially nitrogen from the air. So these microorganisms are very important, especially in agriculture point of view. These microorganisms are very important when we see the soil in a fertility part. These microorganisms plays a major role. And also these microorganisms will release some carbon dioxide for their respiration purpose. And also when these microorganisms are died, or when the microorganisms have passed away, so their bodies also will contribute, their bodies also release some nutrients, some ions, so thus ions also will contribute to the soil weathering process. So this is regarding the soil microorganism process. So with this, thank you very much for listening this lecture, and please subscribe to my channel, Our Soils. Thank you very much.